Good afternoon to all of you. Um, I came to discuss the pharmaceutical organic chemistry, the continuation part of the evidences in the structural elucidation of benzene nucleus by the Kekulé. And in the last class, we discussed the analytical evidences, how Kekulé and different scientists contributed in the structural elucidation of the benzene nucleus. In that part, how they designed different molecular formulas for that benzene nucleus based on the elemental analysis techniques. And then these are the different molecular formulas assumed by the different scientists, and among those we correlated the actual organic compounds like alkenes, the characteristic chemical reaction, the characteristic nature of the alkenes we compared to understand that benzene nucleus, because of in these all assumption structures there is a possibility of existence of unsaturation, and unsaturation we have a most familiar knowledge about the alkenes. The unsaturated related compounds we have most familiarity in the previous semester, that is example like alkenes. Based on this assumption only, we have further studied our concepts about the benzene nucleus. Okay, because of existence of unsaturation in these different assumed structural representations, the unsaturation give one idea about how benzene should be, and we are further move on to study the benzene nucleus as a reference molecule by taking an alkene. Everybody know that alkenes or alkynes are the basic aliphatic unsaturated organic compounds, and those are the basic unsaturated compounds. By using those as a reference, we have one conclusion. Now itself we have a conclusion at the right time, at this particular point of time we have a conclusion that benzene is also behave like those normal unsaturated compounds like alkenes and alkynes. Yes, okay, further. And based on that assumption only, Kekulé conducted that assumed structure. He had taken a benzene sample. I mentioned here benzene structure, but it is a benzene sample. By taking a benzene sample, he conducted the hydrogenation reaction, or else simply we can call it as a reduction process also. We know that reduction is nothing but addition of hydrogens or removal of oxygens or addition of electrons. Here one of the reduction conditions we are going to be planned for the reduction of benzene sample. Why we are choosing this reduction process? Simply we need to observe one thing here, one logic point is there. We are correlating the benzene nucleus towards, or else we are correlating the benzene structural elucidation or structural properties by taking as a reference molecule alkene or alkyne. And here we need to understand that alkenes and alkynes characteristic chemical reaction is an addition reaction. They simply undergo the addition reaction by breaking of the easily breakable covalent bond, that is nothing but pi bond. Same situation we are creating for the benzene sample also, and the basic example for addition reaction is the reduction reaction. Let me see that reduction conditions what we had taken. Through the sample, through the benzene sample, what we had done, passing of hydrogen gas, gaseous representation I mentioned as a upward arrow mark. When you observe the upward arrow mark in the chemical reactions, if you observe the upward arrow mark, it indicates the gaseous products which are coming out or which are involving in the reaction. If I mention the downward arrow mark, it represents that it's a precipitate. Mostly we will see in the gravimetric analysis, precipitates we will get. They settle down based on the gravitational force of attraction. Now here we observe that here we are taking the one catalytic condition is that very finely divided nickel catalyst, one of the metal catalyst, which is helpful for speed of the hydrogenation reaction by passing the hydrogen gas through the benzene sample at the respective conditions like 300 degrees centigrade temperature and 300 atmospheric pressure. What is going to happen? We are observing that whether it's showing the same behavior like alkene, same behavior like a simple basic example of unsaturated compound. Yes, it is showing the same behavior but at the drastic conditions. What are the drastic conditions, sir? Here we are utilizing, we are getting the reduced product now, sir. But what you are telling the drastic conditions means that here see the temperature and pressure. Normally alkenes or alkynes, the basic examples of unsaturated compounds, does not need any type of this temperature and pressure conditions. By simply passing the hydrogen gas in the presence of catalyst, they undergo the reduction process, addition reaction. Even though they need those are the minimal temperature and minimal pressure conditions. 3 atmospheric pressure, 20 to 30 degrees centigrade range, it is enough. 20 degrees to 30 degrees temperature, or else 3 atmospheric pressure. These are the normal conditions. At these normal conditions only unsaturated compounds like alkenes and alkynes undergo the reduction process or else addition reaction. But here benzene sample need the drastic conditions. We need to elevate the conditions, external forces. Otherwise that addition reaction we can't expect from the benzene sample. And what we observed by using this reaction is simply if you observe the product, Kekulé study the final products of this particular reaction. What he observed that the product, it has the characteristic properties of cyclohexane. He observed the products of this particular reaction and he identified that product has the characteristic nature of this cyclohexane and the 6-member nucleus. Okay, by this what he concluded that, let me see that the above product shows a chemical behavior like a cyclohexane. Yes, upon this particular reaction everything happened through the assumption only. Benzene molecular formulas, we have the different types of we have the one molecular formula C6H6 and we have the different assumed structures. From those assumed structures we identify the one logic point. There is an unsaturation is a common point and we concluded that okay, definitely unsaturation must and should be there in a benzene sample or benzene compound, and that unsaturation we correlated with the basic examples of unsaturation compounds like alkenes and alkynes. And based on this correlation only, based on this comparison only, we continue our study process like this by conducting an addition reactions. After this reaction, what are the product we got? On that product our studies are continuous. What happened there? The above product shows a chemical behavior like a cyclohexane, yes, and provide an assumption on the structure of benzene as hexagon shape. This reaction, until now we have an idea about that benzene sample is having an unsaturation only, but by this reaction we have got an idea about the shape of the molecule is, it is hexagon shape. It is a cyclic ring system. Okay, this is the second conclusion about the benzene nucleus. Next one. Each corner of hexagon ring occupied by the one carbon atom, and each carbon has attached with one hydrogen with alternative single and double bonds maybe. This is a second assumption. First assumption is unsaturation is there based on the different assumed molecular structures, molecular representations. Second assumption is based on this reaction we have the hexagon shaped ring like cyclohexane. By this we concluded that okay, benzene also has a hexagon ring. Okay, fine. Then continuation. Hexagon shape give an idea that okay, in the benzene nucleus what we assumed the molecular formula C6H6. We are some elaborating this formula. How can we elaborate this formula? By this product. If you observe this product, if you observe this cyclohexane product, it has 6 corners. 1, 2, 3, 4, 5, 6. What we assumed that okay, benzene has hexagon shaped structure, and hexagon shaped in the sense it has a 6 corners, and each corner occupied with the one carbon. Each corner in the hexagon shape indicate the one carbon itself. Okay, further, and each carbon further has one hydrogen itself. Then how many hydrogens should be there in the benzene molecule? Total 6 hydrogens. We have the molecular formula based on the analytical evidences. On the elemental analysis, we got the molecular formula is C6H6. Here the assumption is that benzene is a hexagon shape. In the hexagon shape, each corner indicates the one carbon, and each carbon further has one hydrogen. Total 6 carbons are there at the 6 positions, and along with that each carbon has one hydrogen. Total 6 carbons, nothing but 6 hydrogens. 1, 2, 3, 4, 5, 6. And for this there is a one support is that here we need to understand that, see the reaction here, there is a 3 moles of hydrogen gas we are going to pass. How many moles of hydrogen gas is required here? It is 3 moles. 3 moles of hydrogen can reduce only 3 unsaturations, 3 double bonds. Simply we can say 3 double bonds, or else we can say that 1 triple bond, 1 pi bond, 1 double bond system. In a molecule, if 1 triple bond is there and 1 double bond is there, there is a possibility of consumption of 6 hydrogen atoms or else 3 hydrogen molecules. To reduce 2 double bonds, there are the 4 hydrogens required. To reduce this 1 pi bond, there is requirement of 2 hydrogens. This is a one possibility. Total 6 hydrogens can be reduced this type of system. In a benzene nucleus, we can expect that type of system also. So there is assumption that each corner indicates one carbon, and at each carbon there is a one hydrogen should be there, and See here, there is this alternative single and double bonds. Maybe this is an assumption only. Alternative single and double bonds. For example, if it is right, if you mention the representation like this, this is a possible representation of the benzene molecule with the alternative single and double bond systems. Now I have an idea about the benzene nucleus. Why the benzene structure should be like this? Why not in another format? I am going to consider in another format. Yeah, it is okay, fine. It is agreeable. It has a 3 double bond systems, and it can possible to consume the 3 moles of hydrogen gas to undergo the addition reaction. 1 unsaturation, 1 pi bond can reduced by the 2 hydrogen atoms, or else 1 mole of hydrogen molecule. But here 3 double bonds are there. In 3 double bonds, 3 pi bonds are there. 3 pi bonds can consume the 3 moles of hydrogen molecule. Hydrogen existing as a diatomic molecule. One molecule of hydrogen has 2 hydrogen atoms. We have everything, this basic knowledge. There is no confusion about the atom and molecule. We have a differentiation among them. Right, I have another assumption of the benzene structure. Okay, hexagon shape is okay, but what about this alternative single and double bonds? Let me arrange in a different manner. Let me see what is going to happen. What is my assumption? I want to include the unsaturation in this way. I want to include, right? Let me see here. This is a representation. What is going to happen? Let me see let me expect the same molecular character, same molecular formula. We know that benzene molecular formula is C6H6. We can expect the same molecular formula, same composition if you assume this type of structure. Let me see that. Now see here, each and every corner indicates 1 carbon. Okay, fine. Total here 6 carbons are there. I got the composition about the carbon. There is a 6 carbons are there. Now what about hydrogens? Let me count them. And before going to count this number of hydrogens, we need to know about the carbon valency, how it is going to be satisfied. Let me see one by one. Now first of all, I am going to check it out, this carbon. Carbon valency is 4, and here see, one valence is satisfied here, another valency here satisfied, 1 sigma bond, and another sigma bond here. They are satisfied here. Now if 3 valency is satisfied, if 3 valency is satisfied surrounding the carbon, still how many is remaining? 1 valency is remaining. Total valency of the carbon is 4. 4 electrons should be there in the outermost shell. If 3 electrons in the outermost shell involved in the covalent bonding, still how many are remaining? 1 electron. That electron, we can assume that there must be a hydrogen to form a relationship with that. Then what happened? Here 1 hydrogen is there. Okay, fine. Now coming to here, double bonded carbon. Now let me see here. Here also same, carbon valency is 3 satisfied, and here also 1 hydrogen we can expect. Then remaining, here see, there is a 1 carbon here, carbon covalent relationship. Here carbon to carbon 1 covalent relationship. Total 2 valency was satisfied. Now still how many valency is remaining for the carbon? Again 2. Here we can expect remaining 2 valency is satisfied with the 2 hydrogen atoms. Let me see that representation. This is 1, this is 2, Same opposite, if you observe here, there is one carbon, there is one hydrogen, here it is another hydrogen. Now if you see the triple bonded carbon system, the carbon valency was fully satisfied with the carbons only. There is no further atomic species there. Now let me check it out how it can be say that. Now if you see that this carbon valence is satisfied here 1, for this carbon 2, this pi bond 3, and another pi bond 4. Total carbon valency 4 electrons are neutralized or else form a relationship with the adjacent carbon atoms. There is no chance to get the relationship with the hydrogen here. If you check it out, this one also, there is a possibility of existence of the same molecular formula like C6 and H6. Why not this molecule representation is not like this? Why Kekulé stated alternative single and double bonds? There is any reason? Let me see the continuation discussion. How Kekulé give the reasons why is pointed out that benzene structure has a hexagon shape. In the hexagon shape, alternative single bonds are there in the benzene nucleus. How it going to be give the justification about that? Let me see. Now next one. If you see here the continuation part, to give a justification what Kekulé is going to be done. The benzene is treated with bromine in the presence of respect to catalyst. Here see that ferric chloride and AlCl3. Ferric chloride or aluminum chloride, those are acting as a Lewis acid catalyst. Lewis acid in the sense, what is the meaning of, what is the definition of Lewis acid? How can we describe? Lewis acid is a lone pair acceptor. That means lone pair acceptor in the sense it can act as a deficient species. This ferric chloride and aluminum chloride. Now what is the purpose of conducting this chemical reaction? If you see that, only one compound with the molecular formula C6H5Br forms. Now here what we need to observe in this chemical reaction, benzene which was Kekulé had taken, specifically if I want to describe better way, what benzene assumption by the Kekulé, he had taken same assumption molecule here. That means each and every carbon has one hydrogen only. He assumed the structure of benzene like this, and he conducted the respect to halogenation process. Here we are using the halogen is bromine. Halogenation process. What is going to be happen here? What Kekulé still have a doubt about the benzene nucleus. Okay, we conducted the addition reaction, that is a reduction reaction. Now let me go for the another chemical reaction, that is halogenation. There is any possibility of addition reaction? Still there is a double bond is there. If 3 double bonds are there, we can expect the addition reaction here also. Let me see that. And benzene but does not, instead of giving the addition reaction, it is going to be give the substitution reaction. How it is going to give the substitution product? At each carbon, according to Kekulé assumption, there is a one hydrogen, and that hydrogen is replaced by the another group, that is our reagent halogen, bromine. In a benzene nucleus, its original structure, in that the original group of the benzene molecule, that is hydrogen, is going to be replaced by, substituted by the respective reagent molecule, that is bromine here, and we got the molecule is bromobenzene. Now based on this assumption only, Kekulev pointed out that benzene as like a reduction process, everything doesn't happen. Every type of addition reaction is not possible for the benzene nucleus. Only the thing is the drastic conditions. Now let me see the continuation part. By this reaction we concluded that every carbon must and should has one hydrogen, and that hydrogen only replaced by the another species. And this entire give the assumption that okay, benzene does not follow the addition reaction completely 100%. Its characteristic reaction is substitution reaction. And let me see the continuation. From above reaction, chemists concluded that benzene does undergo chemical reactions. Yes, they undergo chemical reactions, but its characteristic reaction is substitution rather than addition, and that all 6 carbons and all 6 hydrogens. Based on this reaction only, Kekule gave the conclusion and justification why he told in the hexagon shaped ring, if you see that hexagon ring, alternative double bonds. He gave the justification based on the hallucination reaction only. Instead of addition reaction, at each carbon, that whatever the hydrogen is there, that is going to be replaced by the another species. That is the only reason why he gave the conclusion that benzene has a alternative single and double bonded systems. Okay, fine. Okay, alternative single and double bonds are there. Okay, fine. Then why it is not having the characteristic reaction, that is addition reaction, because of its unsaturation? Why it does not undergoing the addition reaction as like a normal unsaturated compound? There is any special character? Same unsaturation we are observing, whatever it is, alternative is there, side by side is there, cumulative type is there, whatever it is. There is unsaturation we are observing. Why it does not undergo the addition reaction? Why it needs some drastic conditions? Let me see the continuation part. Master, అయిపోయిందా హాఫ్ అన్ అవర్ అయిపోయిందా?